Hi everyone, I'm Ophélie Chopin and this lecture is about oceanography in marine renewable energies. So to quickly present me, I gathered some icons about what I do. So I'm an engineer and I've discovered recently oceanography. So I'm trying to do research in this field and um, I wanted to show you a couple of my passions in order to show you that you can be anyone and do everything. So I really hope this presentation you're gonna enjoy this presentation. But before we go into the details, I will try to present one of the main reasons for me that oceanography and marine renewable energy are necessary in our world. Then I will try to gather for you most of the domain encapsulated by the oceanography, and I will highlight which one is related to marine renewable energies and why. Then I'm gonna back up the sources of marine energy that needs to be assessed thanks to oceanography and the related technology. This will lead us to a summary, brief, and a conclusion, and I hope that you will enjoy this class. Therefore, this is very simple. My motivation is really, really simple. So this is a map of our planet by night, and you can see that basically most of the people are living on the coastline. Actually, 40% of the world's population live within 100 kilometers of the coastline. Therefore, marine renewable energies, so that comes from the ocean to power those towns, us living near the coastline, is really relevant to do that. And oceanography helps to understand the marine biology, every ecosystem that is near or far from those coastline, and therefore are extremely linked to marine renewable energy. It's an entire system that works basically together. So here we go. We are starting with oceanography. So what is oceanography? So oceanography, how can I say that? It's a bit of everything. It's not very clear, but what is clear is that there is a lot of domain in oceanography. And I must highlight here that people don't necessarily agree on what is part of oceanography or not. So I'm going to try to give you a big, broad overview of it, and then you may discuss what is or is not, but this is the general point of view. So first you have the chemicals, the chemistry. This is not my area, but I think it's really relevant because basically it affects every single living organism in the ocean and probably us too. So this is very important to understand this, and therefore it's very connected to biology. So biology is more probably you assess more animals, right? So you would have and plants. So you would have maybe the whales, dolphins, but also corals and all of that. This is followed by a branch that some people say is oceanography, some people say it's not. So I put this weird line in order to highlight that, but it's social oceanography that consists in the interrelationship between humans and all of the other domains of oceanography. So especially maybe biology, chemical, and how we act towards the ocean. Another element is basically all of these that I gathered together. So you have geodesy, geomorphology, geology, geography. Generally speaking, if to try to be broad for you to understand, it's roughly the assessment of the bathymetry and the topography of the ocean. And this is affected by many different factors, also chemical, also technical, and therefore it's a very broad and difficult research. But it is really, really necessary for our field to do so. Otherwise, you don't know where to go and how it is below you and all of that. So it is really important. Then you have meteorology, the meteorology aspect of oceanography, and that is more technically called paleoceanography. The idea is to try to understand in the future and in the past and how tomorrow the ocean is going to be. So is it going to be harsh condition and how the related meteo is gonna behave. So all of that is kind of inside this meteorology. So again, It's one of the other very important branch of the oceanography. And that's the one I know most is the physical oceanography. So in the physical oceanography, you have two types of it. And first you have the dynamics. And inside the dynamics is more like things that are in movement. So I believe hydrology, hydrography is part of it, but some would argue that it's more probably from geodesy. But then you have the tides, the currents, the waves, and the wind. And basically, those are in permanent movement. And then you have the things that are a little bit more what you would call static. So, for instance, you have the density of the water, the color. Color is really important. It's really related to chemistry also. So, it says the color of the ocean. And you have salinity, temperature, acidity, and gas amongst the other elements. And this is there is a strong interconnection here between chemical chemistry and this physical oceanography. Similarly, in chemical chemistry, biology, there is another branch of the oceanography that is biochemistry. And this is basically a little bit mix of the two, as it sounds, right? Okay. So as I mentioned, hydrology, hydrography can also be related to everything about geodesy. So it's not extremely clear for me, but I think this is a link to create when you think about it. Similarly, physical oceanography and meteorology are really interconnected because, well, when you do the meteorology, really often you look at things that are more related to the meteor, right? But meteor may be more for the ocean. And so you will have things like how the currents are going to be, how the tides are going to evolve. And then you also have how the temperature is going to be outside, inside the water, etc. So there is a very strong interconnection between the different branches. In order to understand all those different branches, oceanography is interconnected with space research and science. So satellites are really useful to map, to cartography, and to measure all those many of those different elements. And then from it, these data are analyzed and the cross with other source of analysis, for instance, boats, measurements from boats, and from that you're gonna have like a complete overview of what's going on and detailed overview of what you actually want to see. So, for instance, what is the color of the ocean for chemistry, for instance, or maybe for me it would be more like an analysis of the wave. What is the wave height in the ocean? Because the satellite enables to see how the ocean surface is higher or lower, etc. So it's very interconnected. So it's very interesting. And additionally, you have engineering that is part of the whole thing, because often what you would do is that you would create your own gear in order to go to the ocean to do your measurements. And so you need to understand some electricity, some mechanics, you need to understand a little bit of everything in order to conduct some sort of oceanography. So it is a very broad and very complete picture, and it makes it a very extremely dynamic domain. Hence, the many discussions that sometimes agree, sometimes don't agree on what belongs or don't belong to oceanography. To come back to our main subject, that is the second main subject, that is the marine renewable energy. I try to highlight here a bit clumsily the elements that are more related to the sources of renewable energy. So this is a picture of how things may look like. So you can see here you have a wind farm, what we call offshore wind. So here, these little things here are moving back and forth under the action of the waves. And here you have elements that are more related to the tides and the currents. And there are some additional technologies that are a bit less physical, but more based on chemistry, such as, for instance, everything about salinity and temperature, marine renewable energy. So once you know that, you need to know that all these elements are related to the fauna and flora and create main source of restrictions for the different marine renewable energy. So this is really important to keep in mind because if there are like protected areas because of fauna or flora restrictions, we will not be able to install a renewable energy there. Or maybe we can install some, but it's going to be limited. And another source of limitation that is very important to install a device is elements like social elements, as well as bathymetry, including the distance to shore and all of that. So these are elements that are going to affect the choice in the technology in many cases. So source of limitations. And finally, this physics, not only physics is used, of course, as to assess the sources of the renewable energies, technologies, but also physics related to meteorology is really important in order to forecast what's going to happen in a couple of years, to try to understand, based on this study of the past, what will happen in the future. Because you may design a farm, you may design a technology for certain conditions that you're going to experience today, but maybe tomorrow, or maybe in 10 years, those conditions actually exactly here are going to be very different from what you're experiencing today. And therefore, these are very important to assess, because generally those farms have more or less 25 years lifetime. So this is a very long time, and a lot of things can change in the meantime. So for you to understand that more in a 3D way, I wanted to back up like those sources for you to be able to understand better what's going on. So when you look at sources for marine energy problem, you have those different elements that I mentioned, especially related to physics, right? To the physical oceanography. And not only, also to those assessments of geodesy, etc. So the bathymetry. So this is one of a very important factor, bathymetry. Okay. Then, and the bathymetry is indeed the distance between the seabed and basically the top of the water, right? So the sea surface, what we call. And so you will have an offshore wave, a wave that comes from offshore, so that comes from the ocean, and that's gonna go and move towards the coastline. That's the incoming wave. And this incoming wave, when she moves towards the coastline, she's gonna be changed because of the effect of the bathymetry. As the bathymetry changes, the wave is gonna change. Okay? And this is also due to the effect of the wind. So that is another source of marine energy. So it's going to affect the wave, and the wind is also a source of generation of waves. So this is as well as a source of marine energy. So this is really important as well. Then you will have the tides and the currents. And basically, the tides are phenomena that are affected by the moon and the sun. In addition to the planetary rotation of Earth and different astral elements. And so it is these tides and currents are an additional source of energy for the marine renewables. So they move back and forth, they have different cyclic or non-cyclic movements. And so the study of the tides and the currents is a very, it's a very deep research, as well as for the waves and all the other elements of the oceanography. They all have their own personality in some ways. Then with associated to the waves, you would have the fluid motion. So having in mind that if you look at a point and you see a wave that pass by, in fact, the point is going to do a cycle and a cycle and a cycle and a cycle. And then this cycle, this ellipse, because offshore it looks more like an ellipse. And the more you go to the near shore, the more this ellipse is going to be a more ellipse. So an ellipse from a cycle that then moves because it doesn't have space to move as a cycle towards the coastline. You see here you have less space to do exactly the movement you want than here. So the fluid motion is important as well. And another sources of, as I show you, of renewable energy is the different mixed layers. So because if you go to swim in the ocean, right? If you go to swim in the beach, sometimes you will feel, it's hot. Sometimes you will feel, it's cold. Okay? And so this is the sensation of what we will call, technically speaking, mixed layers. It's layers in the water column, so within the bathymetry. It's layers of different density, different temperature, different salinity, etc. So and you can experience it every day when you go to the beach. Even in a swimming pool, you can feel sometimes such difference. And in the ocean, this is a very important phenomenon as a source of renewable energy for the coastal areas. Once you understand the main source of energy, having in mind that they are more, maybe less known, I can illustrate a bit more to you the marine renewable energy technologies. Here are examples of the wave energy converters that capture the energy from the waves under the action of the fluid motion. So the fluid motion is going to either, for instance, move this device back and forth, or this buoy up and down, or this snake is going to be under action. And basically, the mechanism inside the different devices is going to be able to harvest the energy from the wave, from this motion, and this energy transmitted onshore can be converted into electricity for your own use in your house, for instance. Then research is developing solar farms producing energy from the sun, as it sounds, right? It's very interesting. It's very interesting to put floating solar sign for countries where basically they have more water on the land, or they have restricted area in terms of land. So it's more interesting to have floating solar farm as the ocean is sort of vast. Then you probably know the most well-known MRE, so marine renewable energy, the offshore wind. It's already installed in the northern European waters. And here I'm showing just a particular example that is like a floating platform. But they may diverge. For example, there are also like a direct offshore wind that is standing on the bottom of the ocean. Similarly, you have the underwater turbine to harvest not the wind, but this time the current and the tide. And here again, they may be like different shape, and I'm just showing one example here. Finally, this is an example of what I would say a fancier technology, more based on chemistries and mechanics in some ways, the ocean thermal energy conversion system. And so basically, OTEC use the fresh water from the bottom of the ocean with the hot water from the surface, basically, to create energy in some very fancy way. To summarize, we first looked at oceanography as a multidisciplinary domain that gather different, indeed, domains like biology, chemistry, physics, meteorology, and geophysics. We called bathymetry, water depth, right? And we also saw that there are some doubts in what is and what is not really part of oceanography. So, for instance, there was a discussion about the social oceanography, but there may be others. Moreover, we saw that oceanography gathered and needs other subjects that is more related to engineering and space sciences, like we saw the satellites and the need of gears in order to do the measurement. Then on this figure, we highlighted the four weird boxes that highlight the interconnection between the marine renewable energy and the oceanography, especially related to the restrictions, the limitation, and the projection, as well as the marine energy, the technologies. We overviewed the different sources for each technology with different examples, but I wanted to highlight again that there are other type of marine renewable energy, for instance, based on the salinity of the water, called retarded osmosis. This is just one of the examples. And finally, I would like to highlight a point that I think is very important, is that certain MRE may have very, very, very different shape, and therefore some may be good in some location and some may be good in other locations. So it is, the whole thing is interconnected, and oceanography is interesting in order to be able to understand where each device is good and engineering is complementary. So it is a very interesting and dynamic domain that yeah, I would recommend, and I really hope that you learn from this presentation. Below is my email in case you have any questions. Thank you very much.